Okay, this is the next example. You are told what u is, although I haven't written it down yet. Just from what I was saying a minute ago in the last example, what do you reckon u will be?
1 minus 2 to the f.
Yeah, it's this thing down here that's making it nasty. It will be 1 minus e to the 2x. So, we try and rearrange this to get what x is. To rearrange this, what would be a good first step to make x the subject of this? What would be a good first step to make x the subject of this? Take logs of what both sides only if one side is e to the something on its own, and it's not at the moment. I wouldn't do that yet. We're trying to get the x on its own.
Minus e of both sides, move the 2.
Yeah, I would bring this thing here over to this side where it doesn't have a minus sign to start with, and move that u over there. That's better. What would come next then? Again, I'm trying to make x a subject. What would come next? Yep, divide by 2. Then I've got one side is just e to the x. At that point, you could take logs. That's the ln logs. And then what do you get on the left-hand side? Yeah, just x, because log of e to the x is just x. And on the right-hand side, you'll have log of 1 minus u over 2. It may be that we could write this out in a way that would help us further. This is log of something over something. Thinking back to the laws of logs, I've got log of, for example, a over b. How can I rewrite that using the laws of logs?
Yeah, so it's log 1 minus u minus log of 2.
Can we just deal with the fraction bit first?
Log a minus log b.
Yeah, that is log a minus log b. So over here, this is the same as log of the top of the fraction minus log of the bottom of the fraction. And log of 2 is just a number. So that might help us later on. Might actually help us now. Because once I've worked out what x is, what has been my next step?
dx by du.
To differentiate it, to get dx du. From what I said a minute ago, if log of 2 is just a number, that will disappear when I differentiate it. So what I've got to do now is to differentiate x equals log of 1 minus u.
What did you differentiate by parts?
Sorry?
You got the differentiation by
No, that integration was the thing you're thinking of by parts. No. Can anybody remember?
You could do the
Chain rule.
chain rule, but there's no need really, so it's one just
So can you tell me what the answer is?
1 over 1 minus u.
Are we all happy with that?
Yeah.
We shouldn't be.
That's the exact thing that wasn't working in the homework, yes. It's just 1 over u, is it?
No.
Yeah.
No.
1 over minus u.
I'm pretty sure that would. That's
Yeah, well, that's what I think it should be.
Look here, what's in the bracket here? What's the coefficient of the u here?
Minus 1.
minus
Yeah. Okay. That's what that differentiates to. Log of x is 1 over x, so we got the 1 over the bottom bit. But there, I need a minus 1 because it's a minus 1
yeah.
u. That's there as well.
Oh, not integration, but that's
Okay.
chain rule.
I made a note that when I taught this previously, I brought people back to a red box rule. So that's the sort of red box rule we've used so far. That if you are differentiating log of a function of x, if you are differentiating log of a function of x, which is what we were doing here, if we're differentiating that bit, what you always get is a fraction, the function of x on the bottom, and the derivative of that function on the top. Okay? So if you are differentiating log of a function of x, it's always a fraction. The function goes on the bottom, and the derivative of that function goes on the top. And if you apply that to here, function of x was 1 minus u, and we were logging our function. So the 1 minus u went on the bottom, and the derivative of 1 minus u, which was minus 1, went on the top. So that's a useful one to remember. I'm going to carry on with the example, but in another clip.